let's deal with the first situation. So here is the very basics. So they give you a graph to say f of x is equals to log x plus 1 base 5. And then they ask you for which values of x will f of x be greater than 1. So now, in order to understand this, first of all, you have to understand how the graph looks like. We can predict how the graph looks like by looking at the base. So here is a tip. Every time it is a whole number or simply an improper fraction, every time it is an improper fraction, right, because you could be challenged by them giving you something like this, so the rules that I'm going to show you will still apply. So every time it's a whole number or an improper fraction, it's always going to be an increasing graph, right? So let's draw a rough sketch of it. I just want to show you something. So I want you to memorize that whenever the base is greater than 1, right? Whenever it is an improper fraction. So it can be a whole number, it can be an improper fraction, right? Whenever it's greater than 1, this will be the shape of it, right? But now whenever it is a fraction, for instance, let's just say it was half, right? So whenever it is a fraction, this is how the graph would look like, right? So whenever it is between 0 and 1, meaning a proper fraction, right? So notice between 0 and 1 is like 0, 1, for instance, which is the same as 1 over 10, right? Or 0.5, which is the same as 1 over 2, right? So whenever it is a proper fraction, this will be the shape of the logarithm graph. So even in the exam, when they give you the shape without giving you the equation and they say find the value of a, and let's say this was a, then already you know what to expect. Then you will be able to make sense of your answer, whether it is correct or wrong, right? So whenever it is improper fraction, it's going to be increasing. Whenever it is a proper fraction, right? So here, let me just make it a little bit clearer. So whenever it is a proper fraction, meaning that it will be between 0 and 1, this will be the shape. So this will play a role when you're solving. So to solve, it's going to be very easy, but there is a tip that will come from here. So let's start with the very basic. So they give you this particular graph. Let me just try and just erase this portion. So now they give you this particular graph and they ask you for which values of x will f of x be greater than 1. So now what you're going to do is that you're going to first of all just simply substitute. So then it's going to be log x plus 1 base 5. Right? So log x plus 1 base 5 must be greater than 1. So now, in order to get rid of the logarithm, you'll use the exponent. So the same way, in order to get rid of the square, use the square root, or in order to get rid of the square root, use the square, right? So because they're inverse operations of each other, right? So it's going to be the same with logarithms and exponents, they're inverse operations of each other. So in order to get rid of the log, what you have to do is to put the exponent, to put the base rather to the power of this. What do I mean? For instance, let's just say we've got log 5 base 3. In order to get rid of the log with the 3, I just have to raise 3 to the power of that. So if I raise 3 to the power of that, why is it 3 to the power of that? Because the base is 3. So basically, whatever base is there, you have to raise that base to the power of whatever is here, right? So now notice what will happen. Because this is an exponent and the bases are the same, this literally cancels and leaves me with a 5. Literally. So just one little example before we continue. So here is another one. For instance, let's just say we've got maybe log x base half and you want to remain with x only. Then because the base is half, you have to raise half to the power of whatever is there. So it's going to be half to the power of log x base half. So notice what will happen. This will cancel. I will literally be left with x. So it's the same thing we're going to do here. So we want to get rid of the log and the 5 so that we can remain with x plus 1, so that we can be able to solve for x. So what we're going to do is that we're going to raise, because it's base 5, we're going to raise 5 to the power of whatever is here. So I'm just going to write it the same, right? So 5 to the power of log x plus 1, because this is x plus 1, right? Base 5. So now what I do to the left, I have to do to the right. So I'm going to say equals to 5 to the power of 1. So because I raised 5 to the power of this stuff, also in the right I have to raise 5 to the power of 1. So notice what will happen. It's going to be simple. This will cancel this and I'll literally be left with x plus 1 is greater than 5 to the power of 1 is just 5. Right? So now notice what will happen. So this will become x is greater than, so if I take 1 to this side of the equation, it's going to be 5 minus 1, which will eventually be 4. So it means that the answer is x must be greater than 4. Now, how does the shape play a role in this question? Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement. If you're interested in knowing the prices, the video that contains the prices and the updated contact details, just in case these ones have changed, is found at the end of this video. So here comes the explanation. So you always have to have a picture of a sketch. They would have already asked you to draw the graph before they ask you this question. But if they didn't, you have to make a rough sketch. But obviously, it's not a must to show them. You don't have to show them the sketch because it's literally too much question. I'm showing this for people who want to get total in functions. So you have to always have a rough sketch. Either they would ask you that before or you will have to do it. So now notice that x here is an improper fraction, right? It's bigger than 1, so therefore this is going to be the shape of the graph, right? So now our answer was x must be greater than 4, so let's just picture that 4 is here. So let's just picture that 4 is here. So now notice it's greater than 4, so it means it can go as large as possible up until infinity. So when you see that, it means there is nothing to change. But now if it was less than 4, notice something, right? Notice that there is a boundary, so the graph cannot go beyond this asymptote, right? So I'm going to show you something. Let me just explain something a little bit about the asymptote. So let me just explain something. I just want to show you something before I proceed with this, because this is very important. From this, how do you tell the asymptote? You can actually tell the asymptote by this. So they're rather most likely to give you a graph like this. They like testing with the basics, right? But just in case they test with a high level. So if they give you something like this, notice there is nothing here. It just means the asymptote is 0. So that is why the asymptote would have been at 0, right? So that's for the original situation. But now, if they put a number here, the asymptote, this is actually p, right? Notice that p is always the opposite. For instance, in exponential graph, we've got x minus p, right? So meaning that if you see a hyperbola like this, then you would say that, okay, since it's 1, my asymptote will be at since it's minus 1, rather, my asymptote will be at 1, right? So whenever you're drawing the asymptote, you always contradict the sign. So it's going to be the same thing for the logarithm graph, right? So notice that here, this is going to be in the form of, so I just want to write, this is not the full form, it's just the important one. So this is x minus p, and then this is, let's call it b, right? So this represents the vertical asymptote. So now if you see 1, it means the vertical asymptote will actually be at minus 1, right? So now you know two things. You know how to predict the shape. You also know how to predict the asymptote, right? So now let me just draw a rough sketch of this. Alright, so now we see that it's 1, so meaning that the asymptote will be at -1. So let's just picture that -1 is somewhere here. Or let me just try and make it a little bit closer. So it really doesn't matter. I'm just doing this for some purpose. So let's just do this. So let's say this is at -1. So this is the asymptote. And then we see that it's greater than 1. So we already know that the logarithm graph will actually be shaped this way, right? So this is going to be the logarithm graph. So now the question asks for it to be greater than 1, right? So 1 will be somewhere here, right? So in terms of the y value, notice this is y value, therefore this has to be the y value. So greater than 1, so let's just picture that this is 1, right? So now for it to be greater than 1, we got our answer that it must be greater than 4, right? So notice the greater part, actually, it becomes greater when it's to the right. So notice that x must be greater than 4, so there's no boundary, meaning there's nothing to change. But now if the question had said it must be less than 1, we have a slight problem. The problem that we have is that if they say it must be less than 1, notice that for it to be less than 1, it has to be to the left side, right? So you have to look at the question. So how the graph helps you is that it will help you to know whether the question is asking of the left side or the right side. So now let's just say the question instead asked for less than. So if the question had asked for less than, it would be to the left side. Why to the left side? Because as this is the 1 part, right? So this is 1. So as we go to the as it becomes less than 4, it will start becoming less than 1, right? So it will become less than 1, it will continue going down until infinity, right? So there is always two parts of the graph. If we pass this point, it's going to be greater than 1. If we are below this point, it's going to be less than 1. So you have to know whether you have to choose the upper half or the lower half, but we'll do more examples, right? So if it was less than, we would have chosen the lower half. So the problem with the lower half is that it cannot go as less than 4 as possible, right? Because it is not allowed to pass this boundary. So the boundary is the asymptote, right? So whenever you have to choose the left side, you have to consider the asymptote as the boundary. So remember, after we solved, we got x must be greater than 4. But if the question says less than, we would have solved and our answer would have been x must be less than 4, right? Now, if you have this situation, notice that it cannot go as less as possible. So we obviously see that we're choosing the left boundary, right? I mean the left side of it, right? So whenever you choose the left side, you have to consider the boundary. So all you'll do is nothing complicated. All you do is that you tell them it has to start from the asymptote up until that, right? So even if the question has less or equals to, you would put less or equals to here, but here you're not allowed to put less or equals to because it cannot be equals to the asymptote. It can never touch the asymptote. So the asymptote will always have greater than only, right? So let's do another example. All right, here is another question before we go to a higher level. So it is a must for you to know all these levels. So there's going to be level 2 and finally level 3. So before we go to level 2, here is a question. So you can even pause the video and attempt it and let's see how it goes. So now you're given this particular question, right? And then they ask you, so they give you this graph and then they ask you for which values of x will g at x be greater than 1. Right, so I wanted it to be less than 1, but anyways, we'll do when it's less than 1. Alright, so now let's do this. So let's do this. Matter of fact, let me, yeah, it's fine. Let's just continue. So now, they give you this stuff, so obviously you're going to solve, right? So you're going to say, what you're going to say, because g at x is equals to this equation, so you'll just make it equals to that. You're going to say log x minus 1 base 2 must be greater than 1 rather. So now, because we want to remove this stuff so that we can be left with x minus 1, you're going to raise 2 to the power of this stuff, right? So it's going to be x minus 1 must be greater than 2 to the power of 1. Remember, what you do to the left, you do to the right. So in order to get rid of this, we have to raise the same base to the power of this stuff. So now this will cancel and we're literally going to be left with x minus 1 must be greater than 2 to the power of 1 is 2. So when you take this to the other side, we're going to end up having 2 plus 1, which is going to become 3, right? So now it means that x is greater than 3. So drawing a rough sketch, we see that this is greater than 1 still, so it means that the graph will be as normal, but we have to consider the asymptote. So the asymptote here is minus 1, meaning that it's going to be at 1. So it means we're going to have it at 1. So therefore this is going to be the graph. The graph is going to be like this because it's greater than 1. So they ask for it to be greater than 1 in the y value, right? So we want it to be greater than 1. So let's just picture that this is 1. So if we want it to be greater than 1, is it the right part or the left part? So obviously we can see it's the right part. Besides, also when we're solving, we got x must be greater than. So it told us that it is the right part, right? So we got the right part, so x must be greater than 3. So looking at this, so x must be greater than 3. Alright, so it's the right part. So notice that there is no upper boundary, so it can go as high as possible, right? So meaning that our answer literally stays like this. So now I want to change the question and I want you to pause the video and attempt it. So now let's say they ask you for when will it be less than 1. So if they say less than 1, so you can pause the video and attempt it. So now if they say it is less than 1, so what you're going to do is that you are going to substitute, obviously, right? So we're going to have log x minus 1 base 2, it must be less than 1, and then in order to get rid of this, we have to raise 2 to the power of, right? So we have to make it the same base, so then it's going to be x minus 1 base 2 must be less than 2 to the power of 1. So this will eventually cancel, and we'll have x minus 1 must be less than 2, right? So we take that to the other side. It means that it must be less than 3 because it's going to be 2 plus 1. So notice that it must be less than 3, so it's the left boundary. So here is a problem. The problem is that it cannot just be less than 3 as much as possible, right? Because it's not allowed to be, it's not allowed to pass this boundary of 1. So if you do this, you get it wrong because it's not less as possible, because the logarithmic graph does not exist, for instance, when x is 0. So it cannot pass this boundary, right? So now what you'll do is that you'll simply add the asymptote. The asymptote is 1, so you'll simply add the asymptote. So whatever value is here, you'll add the opposite sign of it there in the beginning, right? Always when it's in the leftmost part, which includes the boundary. So now let's go for level 2. Alright, here is level 2, just before the last level. So now they give you this equation, then they ask you for which values of x will f at x be less than. So they ask you for which values of x rather will f at x be greater than. So will f at x be greater than, let's say, maybe 2. So you can even pause the video and let's see how it goes. Alright, so now I'm going to show you a slight problem. So let's just do this. So I'm going to show you something. So let's draw a rough sketch. So we see that it is a fraction. Okay, fine. First we have to consider the asymptote. Notice that there's nothing here, meaning the asymptote is at x is equals to 0, right? So it's just at the y-axis. So now this is a fraction, right? A proper fraction. So therefore it means it's going to be a decreasing type of graph. So I'm going to come up with a shortcut to do this afterwards. I'm just going to explain a certain rule so that even if you don't draw the sketch, you'll be sorted. So I'm going to show you this. You're going to be sorted even without the sketch. So now, but I want to show you from the sketch so that you understand what's going on. So here is something. They said it must be greater than 2. So if we solve it as normal, let me just show you the problem with solving it as normal. So here is the problem with solving it as normal. Let me do this. So obviously if we solve it as normal, we're going to have log x base half. Okay, forgive my handwriting there, but let me just try and fix it a little bit. So log x base half must be greater than 2. So now we have to say half to the power of log x base half must be greater than half to the power of 2, right? So now this will cancel, and eventually we'll have x must be greater than half to the power of 2 is 1 over 4. So the problem with this is that it's telling me that if I want the graph to be greater than 2, let's picture that 2 was here. If I want the graph to be greater than 2, x must be greater than 1 over 4. But if you look at it, you'll see that that's not true, right? So x is not greater than 1 over 4 for it to be greater than 2, because as x becomes greater than 1 over 4, the graph actually decreases, so it becomes lower than 2. So for it to be greater than 1 over 4, it actually has to be less than 2. So now it is a contradiction. So how do we fix this problem? Well, the nice thing is that in order to fix this problem is that whenever you see that it's now a proper fraction, what you can do is that if they ask you for this question, you can matter of fact switch the sign of the inequality. You can change the sign of the inequality, right? So you can change the sign of the inequality from the beginning. You'll actually, if they ask for this, you will actually tell them that you'll actually solve, but you'll change the sign of the inequality. So then this is going to be log half base x must actually be less than 2. So then this is going to be half to the power of log x base half. So this must be less than half to the power of 2. So therefore x must be less than 1 over 4. So now it's true, x must be less than 1 over 4. We only have one slight problem, so x must be less than 1 over 4. So the only problem that we have is that now we have to consider the boundary. So every time it's on the left side, we have to consider the boundary. So the boundary is x is equals to 0. So we're just going to do this. That's literally all. Then when you do this, you'll never get it wrong. So just to cut it short, whenever you see that the base is an improper fraction, you can solve as normal, you'll get it correct. Just remember that when it's less than, you also include the lower boundary, right? And then If it is an improper fraction, you are going to switch. So if the question asks for this, you are going to switch, and then you're going to solve. Then after solving, if it is less than, include the lower boundary. If it is not less than, don't include the lower boundary. Then you'll be good. So let's go for the last level. So let's go for the very last level. Right, so here is the last level. Let's say you're given that it must be, let's say you're given this equation, you're given this stuff, and then they say x minus 1. And then they say for which values of x will this particular graph be less than, for which values of x will this particular graph be less than, let's say, less than maybe 3. So what will you do? So you can pause the video and then you can attempt it. Let's see how it goes. So now, looking at this particular graph, notice something. Notice that we're obviously going to substitute. Then this is going to be log, and then we're going to have, okay, so yeah, we're going to have that. So I'm going to show you something. So so remember, this is a fraction. Because it's a fraction, all we have to do is just switch it instead. So this is what we have, right? So now this is what we're going to do. So we're going to first divide by negative. So when you divide by negative, because you can't raise this to the power of without cancelling the negative, or else it will not be allowed to cancel out. So you're going to divide by negative. When you divide by negative, the sign of the inequality literally changes. So we changed it, but then the sign of the inequality causes us to change it back. All right? So always remember, whenever there is a fraction, always change the original question, right? And then now if you have a negative, you literally have to divide everything by negative, and then the sign of the inequality will literally change again. So, but it's nothing complicated, right? Every time there's a negative, the sign of the inequality will change, right? But at the same time, every time there is a fraction as the base, a proper fraction, right? Then you have to change the sign of the original question. So now this is going to become half to the power of log x minus 1 base half. Yeah, forgive my handwriting. Okay, fine, let me just fix it. So half to the log x minus 1 base half. So this must be less than half to the power of negative 3. So now looking at this, we see that it will cancel. So x minus 1 must be, okay, so x minus 1, let's just write it one more time. Come on. Okay, so x minus 1 must be less than. So now this is literally going to be 8. Yeah, it's going to be 8. So therefore x must be less than 8 plus 1, which is going to be 9. So because it's less than, we have to consider the boundary, the asymptote. So from the graph, we can see that the asymptote is positive 1, because here's a negative 1. Therefore, the asymptote is going to be a positive 1. So this is it. We're literally done. So there we have it. Let me just fix something. If the question had this instead, less or equals to, you would have had less or equals to everywhere, less or equals to here, less or equals to here, right? So you would have had less or equals to here. So meaning that in the answer you'll have less or equals to here, but here it's not going to be less or equals to, because it's asymptote.